Okay, so hi everyone. For today's session, we'll be discussing for revision for the quiz 2. Okay, so first we'll start with solving all the mock questions, mock 2 that is. And then if you have any doubts in any topics from week 5 to 8 or anything of that matter, embedded say, you can let me know. So to start with, first question is about which wireless communication protocol is optimized for long range, low power application and is commonly used in IoT deployments. So, if you see, this question is like very important for sort of like IoT itself. So, if you think together, right? So, Wi Fi, what do we have in Wi Fi? It has great speed, but does it reach far? No. And Bluetooth, it is very short range. And if you take Zigbee, it has low power but not long range. And at last, if you take LoRa for long range, what does the name itself suggest is long range. LoRa, long range. So the name itself here it suggests long range. Okay, so for applications like agriculture sensors or flood monitoring, pollution sensors, these all they all use LoRa because it can send data kilometers away while running on a battery for years together. So if you see which protocol is optimized for long range low power application, it is usually LoRa. And moving on to the next one, which of the following field bus protocol is known for its use in automotive applications such as engine control units (ECUs)? So cars have many ECUs like engine control, braking system, it has airbags, transmission, and so on. So they all need to talk to each other with high reliability, right? So which protocol is built exactly for this is CAN bus. And why? Because for CAN, it has noise resistant and then it is fast, it is reliable even in vibrations, and also it handles priority messages. Okay, so why we use CAN? Because of these four main reasons, that is it is noise resistant, it is fast enough, and it is reliable even in vibrations. And another main thing is handles priority messages because that is the important thing in the ECU for the cars. It should know when to have the braking system work, when the airbag should work, and so on. So these all works using CAN. And moving on to real-time operation in the context of embedded system means what it means. So real-time does not mean fast. We have been talking about it since week 1, right? So real-time does not mean fast. It just means on time. It just means that you have to be precise. So for example, like airbag must trigger within a few milliseconds. So they are deadline. So if you take the same example, airbag, you have few milliseconds. And if it takes more than 5 seconds but still works, it is taking 5 seconds, but if this airbag works, we don't consider it as a correct outcome. It is wrong because it should work within few milliseconds. So if you see here, the real time operation, what does that actually mean is must respond within a specified time constraint. For each function, you have specified time constraint. This is for the airbag. Maybe for like let's say video, right? So if you're capturing some real time video call or something, it should be in like nanoseconds or something. It should be like really high and precise. So that way, the time varies from function to function. And what is the primary reason parallel communication is faster than the serial communication? So, taking an analogy, right? So, imagine 8 people is passing buckets of water. So, in parallel, what happened? Eight buckets will go at the same time. But in serial, it will be one bucket at a time. So which is faster? The parallel, right? So if you take the example of that and compare it with the bits, then what happened? All the bits travel parallelly at the same time. So there will be multiple bits which travel simultaneously. Multiple bits simultaneously, and thus it is fast. So it transmits multiple bits simultaneously. And now TCP and UDP.
Excuse me, ma'am.
Yes.
But ma'am, which is more reliable, a serial or a parallel?
Again, it depends on the function you are doing it. Okay, so if you see, if you are looking for a more high precise way or something, then serial will be more precise than parallel.
In the context of range or in the context of faster?
If you're taking the speed, the if we're talking about speed, then obviously it is parallel communication is faster than serial communication always. But if we are talking about range, is the same. Range is a constant factor, right? Range is just like kind of distance if you're taking. So it will be the same for both parallel and serial. But if we are talking about like transferring each bit, so what happens is, if you're having a message, right? So if you're having a message, what happens? Message will be divided into bits and then it will be sent. So if let's say this is packet 1 2 3 4 5, so if one is sent, received, and then if two goes, three goes, then what happens? Everything will go one by one. But in parallel, what happens is everything goes at once, 1 2 3 4 5. So at this time, arranging this sometimes will be a problem. So that way, uh, if you're having something like how important the data is and it cannot be missed at all, the precision will work in the serial.
Okay, ma'am. Thank you.
Okay. So what is the primary difference between TCP and UDP? So when you're on a WhatsApp call and one packet is lost, okay, does the call stop? You think that one packet is lost, as in if you're in a WhatsApp call and suddenly you're not able to hear someone, does the call stop? No, right? So if the call does not stop, then so what calls uses UDP? So when you download a file, that time you want it to be perfect, right? You cannot expect few bits to be gone when you're downloading. So that will have TCP. So now from this, what do you have? UDP does not guarantee delivery, whereas TCP will guarantee delivery. So if you see from the options here, you can see that TCP guarantees delivery of packets while UDP does not. Data loss may happen in UDP, and TCP guarantees delivery of packets. And the reason why, because TCP is wired or wireless.
Can you,
Wired.
ma'am, please repeat what is TCP and what is UDP?
You have idea about the protocols, right? TCP and UDP.
Yes, ma'am.
So what is TCP? So is it wireless or wired?
TCP.
TCP.
TCP is a wire.
Yeah, TCP is wired, and then UDP is wireless. So what happens is, it's common, right? So if something goes through wire, nothing is going to be lost. So that is one of the reason why TCP guarantees delivery of packets. Whereas UDP is what? UDP is wireless. And wireless, there are chances of data loss. And when there are chances of data loss, delivery is not guaranteed. And when there are no chances of data loss, delivery is guaranteed. So the same thing, the main concept is TCP is wired, UDP is wireless. So if you know this, you can easily answer this question, because if it is wired, UDP is more reliable than TCP. No, TCP is wired, right? So TCP is more reliable than UDP. And TCP is faster and has less overhead than UDP. No, UDP is wireless. So the bits travel faster than the TCP, which uses wired connection. And then next it's about packet switching. Which of the following best describes about packet switching? So okay, let's say imagine sending a big box overseas, okay, to some foreign country. Instead of sending one big box, you cut it into 10 small boxes. Instead of sending one entire big box, you're just cutting into small boxes, and then you're sending them individually. So even if one gets delayed and others reach, right? So let's say you're having 10 packets, and now what happens? Even if one gets delayed, others will reach. So let's say these two are lost. I mean, it is delayed. These two are delayed, but all the others 8 will reach. So this is how packet switching happens. There is a huge bundle of data. You divide it into packets and send it individually, so that even if few data takes time, the rest of the packets go reach there. Okay. So if you see here, what describes packet switching is where data is divided into small packets and sent independently, so that each packet is independent of the other, no matter whether the other reaches the destination or no. Okay. Okay. So this is like an assembly level language. What are the final values of AX and BX after executing the following assembly code? So uh, can you tell
Uh,
along? Yes.
let me try, ma'am, first.
Huh?
Can you wait? Wait, let me try. Then you solve it.
I can't hear you.
Hello, ma'am, can you hear me?
Yes.
Let me try, ma'am. Wait for few
Yes.
seconds. Then you proceed.
Okay.
Think.
So you can tell me. So what will the first instruction do?
Move AX 10 means AX
Hmm.
initialize 10.
Okay. AX will initialize to?
10.
Correct. Second
And
instruction.
then
Hmm.
BX is initialized with 20.
Which is initialized with 20?
BX.
Ah. Okay.
And then add
Hmm.
AX equals to add 10 plus BX, which is 20. So it
Uh,
is 30.
where will be 30 stored?
Means add AX. That means AX, BX is get added into AX, and the AX is initialized with 10, so it gets 30.
So AX gets 30.
Yes.
Okay.
And then move CX with initialize as 5,
Okay.
and then subtract BX
Hmm.
equals to BX minus CX, sorry.
Hmm.
Then the value 15.
Okay.
BX get 15.
Okay. Hmm.
And now check the answer. AX equals to 30 and BX equals to 20. One is incorrect. And the AX equals to 30, BX equals to second one is correct. And the AX equals to 20. Third one wrong.
Hmm.
Yes, second one is correct.
Okay. So now let's say I'm trying to, instead of add, I am writing multiply. Uh, let's say, okay, yeah, multiply AX and BX. Then how will you proceed?
Now, ma'am, instead of 30, it will get multiply. Like
Hmm.
AX equals to 10 into 20 means 200.
Hmm. Okay. So you're clear,
And
right?
then, yes, ma'am.
And move, add, subtract. Okay. Okay. This is okay.
It is correct, ma'am.
Yes,
I'm
yes.
wrong or
Correct. Correct. It is correct. This is how you have to do.
thank you, thank
Okay, then you tell me what is ISR. So we have learned about interrupts and interrupt service routines, right? So can you tell me, like maybe a one word also about what is ISR?
you. It's like a interrupt things, which means like we sending some interaction
Hmm.
or interrupt data.
Okay, so I'll give you an example. Okay, so just think, now you're doing your work. Okay, you're sitting and reading or something, you're just doing your work, and suddenly a fire alarm rings. So what will you do? You will just sit and keep on reading, or will you listen to the fire alarm and proceed with the fire protocols?
Listen the fire alarm and
Proceed with it, right? So
proceed with.
similarly, ISR also is something like that. When an interrupt comes in, the CPU will pause everything that's happening and execute the special code which is coming in. The special code is how the interrupt tells. The interrupt will tell that something is going to come. So what interrupt does is, the interrupt will basically call for the ISR. So ISR, what is it? So it is the code that runs in response to an interrupt. Interrupt will call the ISR, and then when this happens, the CPU will stop everything that is happening and it will execute the code that is needed to be done. So now, depending on that, can you try answering like which among these can be the answer?
Maybe the second one, it is a piece of code executed in the response to an interrupt, handle a
Correct.
specific task related to the
Yes, it is a piece of code response to an interrupt handling specific task related to the interrupt. And once this is done, once the specific task is done, it will go back. CPU will go back to where it was there. So that is how the interrupt service routine works. Next is, which of the following best describes the role of the loader in the context of embedded system? So compiler, it will create the object code, and linker will combine the object files, and loader, it takes the final program and load it into the memory for execution. Okay, so what we have compiler which will create object code, then we have linker which combines the object files, and finally the loader that takes the final program and load it into memory for execution. Okay, so if you can see here, which is the role of loader?
it places the executive code into memory for execution.
Correct. And what does the linker do in the compilation process? So just now we talked about linker, right? So what does the linker do? It combines the multiple object
Multiple
files
object.
to
Yes.
one object file. That's it. And what is the current sequence of the boot up process? Can you let me know? Do you have any idea?
No, ma'am.
Okay. So how the boot up process works is, so let's imagine the system is waking up. Okay. So what happens is, first bootloader will start. Always the first. The first will be the bootloader. And then hardware will be initialized. After the hardware is initialized, the application code will be loaded. And once the code is loaded, the execution will start. So that's the sequence. That's the sequence for the entire boot up process. First the bootloader will start, hardware will be initialized, then the application code is loaded, and finally the execution starts. Okay, so that will be this option. And okay, now we are talking about hardware abstraction layer. So what is the role of a hardware abstraction layer in embedded?
It provides an interface for application software to interact with the hardware. Maybe first one is correct.
Provides an interface with interact with the hardware. Yes, correct. So if you see then example, right, what is hardware layer abstraction is the name itself has it, right? Abstraction. So basically you're trying to abstract the hardware things that you're doing from the user. So when a user writes a code, instead of writing something like register level, let's say you're having something like 4002 1012 is equal to 1. So this is basically like you're just setting 1 to some pin. Instead of doing this entire thing for HAL, what do? You write just HAL, you write the general purpose input output, and finally you write pin, and that's it. So basically this English word will abstract this particular register, so the user will not know what kind of registers we're working with or what kind of hardware we're working with. They'll just know about this particular line, which means that the right pin, we are setting the pin to 1. Okay. So that way, yeah, you're right. It provides an interface for the application to interact with the hardware. And okay, so I think this should be simple. Array out of bound. What kind of error is it? Do you have idea about array out of
Syntax error,
sorry?
maybe syntax error or compilation error, maybe syntax error, right?
Okay, so it is not a syntax. So I'll first. So do you know what is array out of bound?
Means like array goes infinite or something. Matlab, means runs infinite time out
No,
of
no. So what happens is, let's say you're having an array. Okay, you're having an array of 10 elements, and you're defining it something like let's say 1 2 3. Okay, let's just take 5 now. Okay, we're having array of 5. Let's take you're having an array of 5 and having 1 2 3 4 5 0. So which index is this?
0.
Correct. So 0 1 2 3 4. So we are having 5 elements. Now in the code, after the initialization, so in the code, if you're trying to, let's say, set int v is equal to, you're doing array of 7. This is called array out of bound error. So what happens is, you have a specific number of elements, but you're trying to access element beyond that. There is no element such thing in the array itself, and you're trying to access beyond that. So what happens is, logically there is no error, right? In syntax also it is correct. Till you run this particular
Yeah,
code, you
got it.
wouldn't know what is the error. Only if you run, you will come to know that there is no such element.
It's a runtime error. Got it.
Correct. So it is a runtime. And okay. Now, which of the following is to define a macro? So, how do you define a macro?
Hashtag define value 10.
Hash define value 10. Okay. This is what you told, right? So, macros do not use constants or variables. Okay. So, they just start with hashtag define and value 10. So, what happens? So, wherever you want to use 10, what will you use?
Can you repeat what?
So in now you're having a set of code, okay, and initially you gave this
Okay.
hashtag define. So wherever you want to use 10, what value will you
Yes.
write? Like what will you use?
Means whenever I use value, then we use 10, right? The value,
Sorry.
I didn't get it what you asking.
Okay. So now I'm giving you hashtag define value 10, right? So that is what
Okay.
we are. So okay. So now let's start with what you're understanding. So tell me, what do you understand by it?
Means whenever I use uh, 10,
Mm,
then we can write only value.
okay. See. So what hashtag define value means is, so let's say in your code you're writing int x is equal to value, okay, if you're writing int x is
Yes.
equal to value, value becomes
Yes.
10.
10. Yes. We initialize x as a 10.
Yes, so what happens is, wherever you want to use 10, instead of writing 10 in the entire code, you will write value.
Yes.
Correct. Okay.
That's
Okay, so this is next is an example of a finite state machine. Okay, so they are giving you states, they are giving you events, and then we have a set of code, and we're trying to figure out what will happen next. So you have three states. One is off, LED is off, LED is on, and LED is blinking. And you have two events. Event button is pressed, and the next one is blinking happens in a sequence. So exactly it is five blinks. So what our question is, current state is off. Current state is off, and even button press also happens. So can you tell me? So now what happens here? So this is a switch case, right? So what happens? How to proceed?
ma'am. Case switch off. If the event
Uh,
equals to switch off, right?
Switch off. Okay, first it is state off, right? So your current state is state off. Let's start with that.
Still,
So your switch current state is
case one.
state. So case one, it will
Yes.
go here
Case.
inside. So
Yes,
here
ma'am.
it will check is event button press. So now
Hmm.
is this true or false? This one?
Ma'am, current state is off, right? No. Then event
Yeah, current state is off. This is state and this is events. No, there are
event.
states
Okay, okay,
and
okay, okay,
events.
okay.
So current state is off. That is why we are coming here because this case is true.
Yes.
Now here
So
if even
in the
Hmm,
question he mentioned that even button is pressed. So event even
hmm,
equals to even brand pressed is
hmm.
right, no?
So it is true, right?
Yes.
So this is also true. This is true. This statement
Then
will
we
work.
produce work. Yes, ma'am.
So what will be the next state? Next state will be like what happens next. So what happens next?
So it's state on.
Correct. It is state on. Correct. So now let's say I'm giving you another question. Okay. So let's say you're having state on. Your current state is state on, and then
Okay.
um, you not even button press. Okay, it is not even button press.
Okay.
So what
So
happens now?
so the second case fulfill the condition state
Okay,
on,
okay,
and then the code moves on the
okay.
set
Before
as
that, okay, okay. Tell me. Sorry. Huh.
then if loop get work and event equals to event button press the condition is not fulfilled and the uh,
Stops it.
break yes,
And then what happens?
then the default condition is like proceed.
Okay. See, that's what. The default condition will not happen. Why? Default condition is when none of the case works. We are
Oh, okay,
going
okay, okay,
inside
okay.
the case, no?
Okay, okay. Okay, got it.
So what happens?
I
Your
forget.
current state already state on. Nothing will
State.
change. It will remain
Yes.
state on.
Yes.
Okay. So you're clear, right?
Ma'am, if the case third is uh like case third condition is giving in the question,
Huh. Okay.
then what will happen?
Okay. So
Means
if you
it's
want,
a or
uh,
condition, right?
it's a or condition. So what happens is, so let's say I am having a question which says me that state blinking is on.
Hmm.
So my question, I'm telling that state blinking is on. State blinking. The state is state blinking, and the event is button press. So event is event button press. So what happens is first it will come to case here, true,
Yes,
and then it will check here if event is equal to event button press. It is true or false.
it's a true.
So it is true. And for or gate, what happens
That's
when is the table true?
yes, ma'am. And the one event got true, then the
Then it
whole
is true,
condition
right?
will work.
So what happens? It is
Yes,
true. So even if I have event as event blink done, even then this becomes zero. This will become one. Even then it will be true.
one. Yes, ma'am.
And if I have both event button press and event blink done, then both are true. Then also it is true.
Yes, ma'am. One of the event get true, then the if condition will get work.
Yes, that's it. So now if I'm telling I have another state 4, okay, let's say state 4 is state not functioning. Let's say state not functioning, okay. So then I'm having a question telling state not function. Then what happens? And let's say
Then
I'm
default
telling my state
condition
is not
got
functioning and even button pressed. What happens?
then the default condition comes into the picture.
And default condition will work. Okay. So now you understand the entire flow, right?
Yes, ma'am.
Okay. Okay. So and okay. Talking about the next one. Next is what type of error occurs due to asynchronous events and the order in which they occur. So, do you have any idea?
Ma'am,
Mm.
I'm little bit confusion. Maybe in the digital, it's a race condition
Yeah, it is race condition, but okay, let me explain you why. So, what race
because
condition is? Mm.
I
Okay, you tell.
answered assuming like digital system. It's a race around condition. That's
Yeah,
why.
yeah. So it's like when two events happen asynchronously, and the order affects the output, right? We will get inconsistent results. Okay, so that is what
What,
we
ma'am?
call as
Can
race
you repeat?
condition.
Can you repeat? I didn't catch it.
Okay, so when two events happen, is okay. Give me a minute, okay.
Okay.
Okay. So, what I was telling about race condition is when two events happen asynchronously and the order affects the output, right? We will get the inconsistent results. So, that's what we call race condition. Okay. Okay. Now, talking about 8N1 protocol. Okay, so we talk, even we had this in quiz one, right? So, what does this mean?
Uh, ma'am, like I forget what this means, ma'am. 8 bit. It's like 8 bit.
Huh.
N means what? What is the mean of N? It's like
Parity,
a
no parity.
what?
No parity.
No parity. Yeah, yeah, yeah. Yeah, no
Yeah.
parity. No parity. Yeah, yeah.
Okay.
No parity.
And one is the one stop bit.
Stop bit. Yes, stop.
Mm. Okay. So now they're telling that we have the baud rate of 9600 and asking how much time will it take to transfer 200 bytes of data. So what we will do is each byte, we know that each byte we will have a start byte and then it will have a 8 data bits. And then we will have one stop byte. This is one stop byte, this is one start byte and 8 data bits. So what is the total number of bits we have? What is the total number of bits? 1 plus
Uh,
8 plus 10. 1,
10.
10. So we have 10 bits in total. So and then what we know? We know that we have 200 bytes of data. So if it is 200 bytes of data, let's say we have 2000 bits. Okay.
Okay.
And next, they are telling that we have a baud rate of 9600. So, to get baud rate of 9600, are you getting my point?
No, ma'am.
Okay, so where did you lose it? Where did you not able to understand?
Ma'am, in the like how you adding these bit, how total bit, how we get total bit 10 bits.
Total bit and bit. Okay. You understood how we got 10 bits, right?
No, ma'am, it's my doubt how
Okay.
we get
So you
10.
understood why we have 1 plus 8 plus 1. So I told you, no, 8. So what does 8 mean?
8 means, ma'am, it's a transferring bit. 8-bit
Okay,
transfer per
8
second.
data bits. And for a particular data to send, we will have a start bit and the stop bit, right?
Stop bit. Yes, ma'am.
Okay, so we have a stop bit and a what do you say? Start bit and a stop bit. So that is why we have one start bit here. If you see, we have one start bit. We have 8 data bits
Okay.
and we have one stop bit. Okay. So what is the total number of bits here? That's why we are adding
Yeah.
it to 10.
Okay, okay.
So any protocol you take, if we, I'm telling you if my protocol is let's say 12 and 1, how it works is one start bit, 12 data bits and one stop bit. So this will give me 14.
Okay.
Okay. So this is how we are getting 10 bits of per like byte. So we are telling that we're having 10 bits per byte. And now the next is at 9600 bits per second, right? So we have BPS. And what is BPS? Yes. So we have BPS. What is BPS? BPS basically bits per second. So we
But
have
ma'am, how
9000.
you convert 200 bits into bytes? Like it's a one byte equals to 8 bits, no? Then how it comes to
Yes, we are
1000
not
bits?
doing that bytes. So here, if you see this 14, or where is it? This 10, no, this 10 here means that 10 bits per byte, one byte. So this 8 in one, right?
Oh,
This
okay,
itself
okay,
is like for every byte.
okay. Means 10 bits per byte.
Yeah, so the first calculation itself is for 10. The addition itself will tell you 10 bits per byte.
Hmm. Okay,
So that will give you simple, no? If one byte we have 10 bits, then 200 bytes we will have 2000 bits. Correct?
okay. Yes.
So next, another thing is, now we have to calculate how much time we need, how much time we need to transfer the data. For that, what we will do is, we will do, you have what, 2000, where is that? 2000 bits, and we have 9600 bits per second. So we will have 2000 divided by 9600, you will get in seconds. So can you calculate and tell what you have? 2000 by 9600.
Hmm. It's ma'am. Zero will get cancelled out, and then like wait, we can use calculator as well. Ma'am, 20.83 millisecond.
You're getting 20 point. It is 20 by
83.
96.
20.83 millisecond.
How are you getting 20.83?
And
So if you
zero
do
zero
20 by 96, it should be 0.2083.
83.
For milliseconds, how much is it?
It's a second, right? Then 208. Sorry, there is a mistake in the conversion.
Okay. So now the answer will be, you skip three decimal points, right, for millisecond.
Yes, ma'am.
So
Second option. Second option.
second option. So now let's say you're having this protocol as 12 and 1. What have you have to do? You got 14. So after 14, how will you proceed? You got 14 bits per byte.
Then we multiply 14 into 200 and divided by 9600.
Correct. Okay, that's it. So you have to make sure, if for 200, for 9600 and all, you have to change it accordingly.
Okay.
Okay.
Ma'am, wait, can I note it?
Hmm. You had some doubt?
No, ma'am, I note it.
Okay. Now, okay, 18th one. So what operation is this?
It's hexadecimal. Oh, greater than means it is a right shift. Sorry, left shift.
Right shift, no? It is going towards right, like this.
Yes, ma'am. My focus is on writing, ma'am. Sorry, ma'am.
Oh, yeah. So correct. Your first was correct. It is right shift. And how much do you have to shift?
2 bits.
Correct. So now let's take having hexadecimal. Now can you convert this hexadecimal to binary? So tell me, what is it?
C, ma'am. A, B, C. It's a 12, I think. A, B, C. It's a 12.
Binary. Tell me in binary.
Tell me a one,
Mm.
1100.
Okay. And this one?
0011.
Okay. Now we got our binary for that. Now we have to do shift 2.
Yes,
So
ma'am.
how will you shift 2 bits?
Everything shifted
This
towards
will
right.
shift to, this will shift to, this will
Shift
come here.
towards this will shift.
It will be
Hmm.
1, 1. One,
one
one,
one one zero zero zero
and the remaining two.
zero zero.
Correct. Zero zero. The empty place zero zero. So
Mm,
now what is the hexadecimal?
it's a 16, right?
Hexadecimal for this.
Zero F. First one,
Correct.
maybe.
It is zero F. That's it. So what is your point? Zero F.
No, if you don't mind, ma'am, can you please scroll your screen and can so I can note per question, the previous
You want
question.
another question to solve, no?
No, no, no. I want to copy the previous question.
This one, okay. Should I write it
Yes, ma'am.
again? Are you able to understand, or should I write it again?
Write it in proper way, like so that I can note it.
Okay. So we have 8 and 1, and we have been given 9600 bits per second, and we have 200 bytes. So the first step that we will follow is we have one start bit, then we will have 8 data bit, and then one stop bit. So we add all this, we will get 10, which is 10 bits per byte. So this is a step 1. Step 2, we take this bytes and we take the 200 here and we do 200 bytes will be equal to 200 into 10. Where did this 10 come from? It came from here. To 10 bits. So this will give us 2000 bits. And why exactly we are converting it into bits is because we have bits per second. No? So that's it. Like when two values are not in the same denomination, we
Yes,
convert it.
yes,
Okay.
yes, ma'am. This is the doubt comes in my mind while you calculating like how you can calculate or cancel two different quantities. It's
That's
a
why
bits
we
per
are
second.
converting it.
Yes, ma'am. I am thinking like it's a byte per second, and the rate is given bits per second.
Yes. That's why we are converting bytes. And for that, we're using 8 and 1, which is basically for every byte. That's how it is defined. For every byte, it says it is 8 and 1. So
Yes,
this
ma'am.
8 and 1, we denote it like that. Every byte uses. Every byte uses. So this, and finally, the final step is to find the time. We will have 2000 bits, and then we have our 9600 bits per second. So this will give us some 0.2083 seconds, and which on converting we will get 0.83 milliseconds. Okay.
Ma'am,
So,
if you don't mind, I why we divided like uh 2000 by 9600
okay.
means I am thinking like we have to divide 9600 by 200 2000, sorry.
Okay, so let me tell you logically and also a trick. Okay, so okay, let's talk. Speed, right? Speed is equal to
Distance upon time.
distance upon time. So what? Time is equal to distance upon
uh
speed.
Distance upon speed.
So now, what is this? Bits per second. How many bits per
Yeah,
second is traveling? What is it?
it's a speed of bits.
So it's a speed. And how far we are going, that is how many bits are we trying to go up far, that is this one distance.
Okay, okay.
Okay,
Now
so
it's better,
this is
clear.
like logically. Okay, next one, talking about a trick itself. So you have a time will be in what will be the denomination of time?
In what
Seconds,
sense? Seconds.
milliseconds,
Okay,
like
okay,
that, no?
okay.
Okay,
Yes.
so now let's say here you take this this denominations here. So here you're having bits, and here it is bits per
Bits per
second is
second.
divided by second, which will go to the top. Bits will cancel, and it is second. But
Okay.
if we are doing bits per second whole divided by bits, what happens? You will get 1 by
Is a
second.
inverse of time.
Yeah, so that is time. But logically, it is this one. Speed is equal to distance by time.
Okay.
So if they're asking you frequency, how do you find frequency?
Ma'am, it's the inverse of time. I'm
Yeah,
telling. It's the inverse of time.
that's it. Okay. So it is this one. No? Take. So okay. So I guess this is pretty much about, yeah. This is pretty much about mock. Apart from this, okay, I think last week we
Ma'am,
discussed
uh,
about.
can
Oh yeah.
ma'am, can you give me brief summary about errors? Because I am a little bit confused syntax error or runtime error or whatever, compilation error, hardware error.
Okay. Okay, we can. So
Like in the which week it
okay.
covers in like week 7 or week 6.
So we talk about mainly three types. Okay. So the first one is compile time. So compile time is like all the syntax error that you have, like semicolon or any mistake, like you have not initialized something but have, like you have not given int v but you directly give v is equal to a plus b. So these all are like syntax error, and these all will be caught early. Caught early is during the compilation itself, before it can go into runtime. Second one is mainly runtime error. So for runtime, what happens is it is basically like that array out of bound. Then you have null pointers. Like there is nothing in the address, but you're pointing to it, and you're trying to access the data. Then you will get like null pointer errors. Then you will have buffer overflows when you're not clearing the garbage and all. You will have overflows. So this runtime is like not caught early. This happens only after we start running the system. So once we start running the program itself, what happens, it will crash in between, which will be a negative effect in the program, because you have already started the program and it gets stopped in between, which is something critical issue. So, third one is logical error. So, logical error is basically from our side. Like, let's say if you had to write a is equal to a square. Okay, so now let's say I had to find b is equal to a square. So, instead of doing b is equal to a into b, I just do a into 2. So this is like logical error from our side. This will not be caught in compilation error because syntax is correct. This will not be caught in runtime also because this will give a proper value. But we will not get the desired output. The output will be wrong. So that is when only after we get the final output, we will understand that the logic is wrong. Okay. And there is another error which we tell is like hardware error. So basically, hardware error is something like it is not a manual mistake. It is just that hardware is not working. Like, or even it can be like pins. You have already seen the board, right? And let's say you have not connected to the pins properly. That means the led you want to glow will not glow because you have not connected to the pins properly. So these all will be like hardware error. Okay. So the main thing is for this entire errors, right? We are not trying to like have completely error free, because it does not happen like that. We just want to gracefully overcome it. We have to just make sure that even if there is error, we should know how to handle it without making a huge scene out of it. Okay, so that is the entire concept of error handling and debugging. So that is why we have, and one of the important thing we discuss is about watchdog timers. So in watchdog timers, so you have watchdog timers. So watchdog timers, why we have is it is like a backup kind of thing. It's like when your programs keep on running, okay, and suppose it gets hanged, then how will you stop? If it is a PC or laptop, you will just shut it down and restart, reset, and you can do something. But for a hardware board, for a microcontroller, there is nothing like that. Like you just restart the computer or something. So that time, this watchdog timers come into place. It will have a specific time that we allocate to it. We will be like after 10 minutes, if you still do not, so there will be a constant signal going to it. So we will tell that if you don't get the signal, then reset the entire system. So it happens automatically. The main purpose is if the program hangs, there should be a reset. There should be a backup. Make sure that it erases something and comes back up. Okay. So this is one of the thing you have to learn when we are coming to error. What you call error handling and debugging. Okay, but this is the
Ma'am,
overall thing about errors. Yeah.
what is the difference between compilation and syntax error? Like it's look like similar, no?
Syntax error is compilation error. So wait.
Means
So
I understand what is syntax error. Means we can like if we do some mistake like semicolon and commas or curly brackets
so
like and
basically, you have a compilation error. Okay, your syntax error is part of compilation error.
okay.
So compilation, even your syntax error is compilation error. It is
Hmm.
basically like, let's say your syntax error is animal, okay? So you will just put donkey in it, right? So donkey is an animal and donkey is also a donkey. Similarly, syntax error is a syntax error and it is also a compilation error. But compilation error can be a syntax error, and there is also, you have heard about explicit and implicit type conversions, right? So let's say you're trying to convert. So when you're trying to convert int to float, it can happen implicitly. It can just automatically happen. But if you're trying to convert float to int, you have to do it explicitly. So let's say you have a float x and you're having a int v. We cannot do v is equal to x simply like this. We have to do something like v int of x. So this is the correct one. But if you're doing something like this comes into compilation error. That is type error. This is called type error. Okay.
Hmm. Okay, okay, ma'am.
Okay. Okay. And week 8 was mostly very theoretical, sort of, and we kind of discussed it with yeah, lots of like examples like home automation and stuff. So it will be better if you guys can like brush through it, like what are the architectures, design architectures. We saw software architecture, so those one, it's like pretty direct. Just have a rough idea about what is what. Okay.
Ma'am,
You have
if you
any?
don't mind, if you don't mind, in week 8, you like you cover error handling. Then we can solve error handling assignment.
Which do you want to solve?
Whole assignment, like in the week 8, uh, we have error handling assignment. In the whole topic, we error handling assignment. So we can like
No, I
solving some
mean,
problems.
you want to do the graded one, right?
Graded one?
Are you asking for the graded assignment or
No, 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 no. It's a practice assignment.
week 8 practice assignment?
Yes, ma'am. Error handling assignment.
Okay. Okay.
As
So,
you covered error handling, so we can apply what you covered in the.
okay. So, okay, we can. Not a issue. Okay. So, for week 8, it's pretty much direct, right? Practice assignment. So okay. So, what is the role of event handler in an event driven architecture? Okay, just try to guess like why would you need a handler?
Because ma'am, we can make mistake when the handling error handling comes into the picture.
Yeah, so that is error handling. Okay, okay. So this is event handling, but okay, I'll tell you what is event handling also. So event handling is something like, so there are so many specific events can occur, right? So event handler is something which will tell you, which will define the actions or behavior that should occur to specific events. So that is how event driven architecture works. So that is one of the architecture. Okay, we didn't cover architecture. So did you attend last class and are you aware of event driven architecture? We spoke about event driven architecture. Okay.
Ma'am,
If
your
you
your
don't
voice.
remember, then I can just like, can you hear now?
Yes, ma'am. It's clear now. Can you repeat what?
Oh, so are you aware about event driven architecture?
No, ma'am. Because ma'am,
It is also part of.
I didn't join previous session.
Okay, let me give you a brief summary of this. Okay, so what event driven architecture means is, so each module, right, it reacts to the events like interrupts or sensor changes. They all happen. Like each module will react to it instead of running continuously. Okay, so events can be anything. Events can be something like a button press, or it can also be arrival of data. It can be like maybe there is a certain threshold, and crossing this threshold, these are all like events. And once the event is done, it will trigger an action. Okay, so it will trigger an action. So that is when this event driven architecture comes in place. We will tell that once the event happens, it should trigger an action. So that's it. So that is the entire thing about event driven architecture. You can also tell something like, let's say you have a busy office, okay, where each person handles tasks only when their phone rings. So that is efficient and responsive, right? So that way, this is also event driven architecture. So to perform an action, you need an event that happens. So what will event handler do is to define the actions in response. It should define that particular actions before that event happens, so that once the event happens, that specific actions will occur. Okay, so it's just like example like what we already saw. We saw an example, right? We saw that there was state on, state off, and so on. And we already told that if it is state on, and then if event button press, then what should happen? The next state should become off. right? So this is entire thing is event driven. So you already have an event, and you're telling that once this event happens, this particular action should happen. That is about event driven. So next is, which type of error handling technique is commonly used. So, which type of error handling technique is commonly used to detect logical errors and invalid inputs during development and testing phases? So, this is one of the um, error handling technique. So, do you want to answer? Like, what? It is the fifth question. Practice assignment, fifth question. Okay. If you want, I can just paste it here and you can try answering.
Ma'am, you solved practice assignment.
I asked you if it is graded assignment and you asked for practice assignment, right?
Ma'am, I told you for the error handling assignment. I open error handling assignment and see which question you asked, and I
Oh, you're
now
talking
you
about the activity questions.
yes, ma'am. I'm searching
Okay.
that like what question you put, like asking, and I'm searching here.
Okay, fine. We can do that. Then we can just go one by one, okay?
Okay, okay, right.
So, yeah, error handling assignment. Okay, 1 minute.
I was like, where is the question?
Okay. I thought you were asking about practice activity questions. Okay. So first is, what is meant by an error in the context of embedded system. So yeah, you can try answering, then I can explain.
Maybe the third one. Incorrect output in arithmetic operation only. That is only one.
So, so
Maybe
let me
first
tell you.
and third is the correct. Maybe
Okay, so it is
one and third.
basically the
Okay.
first one. Okay, and I'll tell you why.
Yes,
So
first.
let's think about what we mean by an error. Right? So it's not just when the program crashes or stops running. We even spoke about an example where the airbag opens after the time limit exits. Right? Even that is an error. So let's say if your temperature sensor suddenly reports, let's say, minus 300 degrees Celsius, even that's an error. It cannot be minus 300 degrees Celsius no matter what, right? So even that's an error. Even if you're getting an output, it is wrong. Not just in arithmetic operations, even logical operations. So because arithmetic is just only about having a plus b or anything mathematically wrong. But let's say logically you have given wrong. Even that comes under error, right? So an error means the system behaves in a way that's not expected or defined. Okay. So yeah. So, moving on to, why is error handling especially critical in embedded system?
Because ma'am, it is a uh, runtime error. Sorry, what we call it? Like it's a constraint because they
Okay,
often
and
run continuously. Because real time operation, ma'am, because of
we also spoke about,
like
no, we also spoke about restarting, resetting, and all. Like it cannot be done like a normal computer, right? So it cannot be like you have a computer, an error came, you'll just shut down and switch it on, or do reboot or something, and the glitch is rectified. That cannot happen in embedded system. So for embedded system, you have to
yes,
make
yes.
sure that you have to handle the error. That's what we spoke, right? So we have to always make sure that no matter whether there is an error or no error, if there is no error, fine, continue with the program. But if there is an error, there should be another set of error handling code which will take the program out of the this particular program. It should not be like suddenly it crashes and it just stops. Okay, and why? Because we cannot restart it easily like a computer.
So we have to reset the whole program, or we have to fix it.
Yeah, so we cannot do it just easily. So we have to make sure that we are handling all kind of error.
Okay.
So which characteristic is highly desirable in error handling systems?
Adding more hardware always ignoring error of speed setting at every failure. Resetting the system at every failure. It is correct. Is it correct?
Resetting.
The system at every failure because we have to reset the system if we get error. Which
Okay, we
characteristic
cannot
is
reset the
highly
system
desired?
at every failure, right? Even the above question tells it. What we have to do, we have to make sure that there is a error handling technique, and how
Graceful
can it
recovery
be? It
is
can be
important.
done by gracefully doing a recovery. Graceful recovery is nothing but error handling. Having a code which will make sure that you come out of the entire program without making a huge scene out of it. You're just coming smoothly.
Okay.
You cannot reset the system at every failure because it's an embedded system. Hardware, you cannot do
Ah,
it.
yes, yes. Yes,
Okay.
yes, yes, yes.
And then,
Which of the following type of error known as embedded system? All of the above?
correct. So it is all of the above. And
What is a
what is
common
the common
convention
convention? Okay. So in C, right? In
for
C, when a function runs successfully. Okay, wait. So in C, when a function runs successfully, when a function runs successfully, then it will give you zero. Okay, and if something goes wrong, you will get like -1, -5, 1, anything apart from zero. So you know that way that if something is successful, you will get zero. If something is wrong, you will get in negatives or positives, anything apart from zero. So now can you answer what is 5?
zero indicates success. Second one.
Yes.
What is the main disadvantage of using a global error flag? What
uh,
is global error flag mean?
okay. So, okay. So sometimes programmers will create one variable, okay, like one global variable. Like so, you know about global variable and the scope, right? For global variable, what is the scope? The
No, no, no.
entire program. The entire program. Okay, you know that no? Between the global variable and the scope for global variable and the variable which is within the function. Do you have any doubts in that or?
Yeah, able means I didn't get what is global error flag. I, I do not get what is global error figure or what happened when your skin is off.
like error flag. So it is like that
Ma'am, I think your network is
all
not.
functions can set an error. So when we but the problem is in systems with
Hello,
interrupt.
ma'am. Am I audible?
Can't you hear me? Yeah, yeah. Am I not audible?
Ma'am, your voice broken got quiet.
Is it clear now?
Ah, yeah. For a
Okay.
couple of
So
minutes,
what I was telling you.
your screen was off for a couple of minutes.
Okay.
I think this
Now
is
it's okay, right?
yes, ma'am. Now it's perfectly fine.
Okay. So what I was telling is okay, okay. Okay. So what I was telling is so for global variable, right? So what programmers do is they will use a common flag called error flag. And why is whenever all functions have any error or something, they will come to this flag and set it to one. So what happens, what the problem is, in systems with interrupts, tasks, or multiple threads, several functions might try to change that flag at the same time. Yeah, at the same time, they'll come and try to change it. So when they come and try to change at the same time, this is what we call as race condition. Okay, so one task overrides another's error and you will lose information. Only one of the error will be available, not everyone's information. So instead of using one global variable, right, we will have local error. We will have local error code for each function. Okay. So that is why we will have. So you understood about global and so let's say you have a function. Okay, if you have an error flag within this function, this will be local. But if you have, let's say you have multiple function and at the top, let's say you have a global flag, then this flag is common for everyone. Then it is called global. So that is the difference between global and local. And what is the main disadvantage is global can be edited by anyone. And so when anyone is trying to edit it, most of the time the values will get over it. Okay. So now can you tell what is the disadvantage of using global error flag?
Maybe second one, it can cause race around when multiple function try to it.
Yes. Yes, they will cause race condition when they try to use the global error function. That is especially when multiple functions write to the same flag. Okay. So now next one, why are assertions not suitable for production code in assertion? So now what assertion can do is they are great during development. Okay. So assertion is something like if you remember, you write some code which says like assert let's say value greater than equal to 0. Okay, you would have seen code using assert. This is called assertion. So what they do is they check if something that should be true is actually true. So this will basically check if this should be true. Is it true? It will check for that accuracy. So if it is not true, what it will do is it will stop the program here and it will just end it there. It will not go to the next line, it will just end it here. So this is good for debugging. If you want to debug the code, it is good that at that point it will stop, so you'll know where the error is. But if you're taking it to production, so what does production mean? It means that live, right? Some humans or users are using it. So you would not want to stop it in between. Let's say you're using some medical equipment, okay? So let's say you're using a medical equipment, and in that medical equipment, you find an error and it stops in between. What will happen to the user? He might even die, right? So so that is the main reason you cannot use assertion in production. Okay, because in production you want the error to be handled gracefully. The error, you have to come out of that error nicely, not just shut the entire program and come out. Okay, so now
Yes,
can you
Monica.
tell why are they not suitable?
They crash the program if the condition fails. Third one.
Correct, correct. And okay, now what are the techniques that are known for additional error handling methods? Okay, we talked about watchdog timers. Okay, so the rest too, what does fail safe mean is, so fail safe is, let's take an example of a lift, okay? So now let's say you're going in a lift and power shuts down. What happens? You're in
Lift
between second
stops.
and third floor, okay? And at that time power is gone. The lift, what happens to the lift?
Lift get off. Suddenly stop.
So the lift is like there is a default fail mode. No? So if it is between second and third floor, it will either go to second floor or third floor and then stop and open the door.
Uh,
Okay, so that is a fail safe. So if we also see, let's take an example of a drone. Okay, if a drone loses signal, it will have a fail
uh,
safe. It will have a fail safe mode where we tell that the drone should automatically land. It should not just fall off. If the signal loses, it should land nicely without just falling and crashing.
or
So
we
these
can
are
say
the,
emergency landing.
yeah. So there should be a fail safe. It's basically having a backup.
Okay.
Not exactly backup, because backup will have a different meaning. Fail safe is like we have a condition, like a default condition which we have for switch case, right? Like that.
Yes, yes.
And now comes redundancy. Redundancy is basically a backup. You know the meaning of redundancy, right? Redundancy means having something which is not required. So something like sensors. Let's say you just want two sensors connected to each other, but having a third sensor is having a backup. So this is redundant sensor, but still we're having it in case anything fails. Automatically, this will come like this. Okay. So this is what we call as redundancy.
So it seems it's all options are correct. All three are correct. And the
Correct.
all of the above.
Yes, correct. Okay. Now moving on to next question. What makes debugging in embedded system more difficult compared to general software? We can give it a try. We kind of covered most of the things.
Um, like real time, constant, and transient works.
Okay, that is one of them. And
And the let me check. Hardware software interaction issue. What makes debugging in embedded system more difficult compared to general software debugging? The third one is also correct, maybe.
correct, correct.
Hardware
Yeah.
software
Because for
interaction issue.
software, we do not care about hardware, but for embedded system, we have to make sure that hardware and software is properly pinned and like properly mapped and so on. And also the first one also, the limited visibility into system state. Okay, because you can't just pause and inspect everything, no, like if it is a software app development or something, you just stop and see how it works and not. But for embedded system, it will not work half and half, you have to complete it fully. So there is a very limited visibility into system state. Okay, so even that is one of the option, limited visibility. And for the infinite debugging, do you think there is an infinite debugging for this particular embedded system? We talked about debugging, right? So there's basically only three kind of techniques. So do you think there are like infinitely many resources available? Are you talking?
I
Yeah.
don't, I don't know about very much about this.
Okay. So basically it is just three types. It is not infinite debugging. You cannot do more than three, right? So it's basically like no, it is not infinite debugging. It is just the
Okay.
first three options because we have very limited resources for debugging. And that is given in the eighth question. You have watchdog timers, you have fail safe and redundancy.
Ah, okay, okay, okay.
Okay. And tenth one, printf. Okay.
What is the potential
So
drawback of
okay, we
printf-based
spoke
debugging
about
system?
this in the lecture itself. Like, what is the drawback of printf? Okay. So printf, we use this very frequently. Okay, we use this very frequently to print messages and see what's happening and all. But in embedded system, this can be dangerous. Why? Is because every time you print, right, it takes time. It will take few milliseconds and so on to send the message to the UART here is the communication thing. So it will take some
Hmm.
time to go there and come back. So that small delay can change how your code runs, because we want this to be efficient. We just don't want it to print and waste some time there. So the timing of the interrupts or events might shift. So even the timing also might shift, and the original bug might appear or even disappear or even can move. Okay, so these are called hasten bugs. So what is, so wait, let me write it. So when you use printf, right, it will use some time to go to the UART, few milliseconds. And in this milliseconds, right, this small delay itself will alter the time. It will create some timing issues. And then the timing of the interrupt or the events might shift. Okay, so
Hmm.
the timings will shift. After that, what happened? There is an original bug, right? There might be an original bug. This bug might disappear or it can move. And this condition is known as hasten bugs. Hasten bugs. So what it really means is they vanish when you try to observe them. Okay. So basically, it's like at this specific point of time, you ask a printf to check this error. But by the time you get that printf and you're trying to come back, this error will go somewhere down. So at this point, when you check, it will be nothing. So it will disappear. So that's what we're trying to tell when you're using printf. Okay, so if we are using printf in early testing, it's okay, but we have to use it when we're using it in a time critical systems, because it will alter the time. So what is better to use is, it's better to use LED or debug pins or hardware debuggers instead. Now coming back to the question. So what is the potential drawback of the printf based debugging system?
It can add the second one. It can add the timing and make bugs disappear.
Correct. Okay. So yeah. So basically, this is all about error handling assessment. It's so. Is there any topics you have in mind, or I think we have pretty
No,
much
ma'am.
covered most of it in mock two itself. So yeah.
Rest of the topic I have to read once. Then the doubt
Okay.
comes.
Yeah,
So
okay. You
that
can
I
just
have to.
post it in the G chat or Discourse or yeah, email also, even that's fine.
Okay, ma'am.
Okay then. Abhirami, do you have any doubts? Okay, if either of you do not have any doubts, then we can end the session for today.
Yes, ma'am. Because we
Okay?
covered almost all of the
Yeah.
topics.
Yeah, I think, yeah, try to go through the lectures, try to brush up all the graded
Yes,
assignments.
ma'am. Because I am not like covered all the lectures, so that's why I have not have any doubt related to the
Okay, so if you're having
like
any
wheat.
doubt, then just post it in GChat or you can email any one of us.
Okay, ma'am.
Okay, then if there's no doubt,
Thank
then
you,
we
ma'am.
can end the session for today. Thank you and all the best for your quiz too.
Thank you, ma'am. Thank you.